Welcome to the weekly HRTV show. You'll notice things are slightly different. I'm currently here with Kevin. Kevin, say hello.
Hello, Kevin.
Yeah, so we are here at the Kevin's Labs. Wednesday for both of us was a little full, so we're sitting here Tuesday night. But everyone is going to be seeing this on Wednesday, so I want to wish everyone a happy Veterans Day as it is November 11th. As some of you might already know, I was in the Air Force for 6 years. I was an aircraft electrician, and my wife is still in the Air Force as a Air Force loadmaster. She's in the reserves, and my grandfather was in the Army Air Corps. So, you know, a lot of family in the military. Drop a comment. Let us know what branch you served, or maybe a close loved one also. So, you know, our hats go off to them. But tonight I want to get to microphones. We're going to be talking about different microphones. I'm holding here a dynamic, or possibly you have a condenser. That's typically what you see me use. These are the same one I use back in my shack. These are the AKG P120s, and we're going to be going over some good stuff. You know, kind of give you a little bit better understanding about microphones. Now, as I sit here and talk, you hear about 85 to 180 hertz. So 85 to 180 hertz as my voice kind of goes up and down, and that's an approximation. Females are typically around 165 to 255. So if you think about that, females, you know, a lot of times have a slightly elevated voice. And, you know, as our young kids answer the phone, they can go all the way up to 300 hertz. And sometimes when you have a young man, I definitely was there, you can't tell the difference if it's a young man or a female. Right. And that's just because, you know, they're there at the higher hertz.
I did want to comment, though, on that. Those numbers that Jason just gave you, no hate mail, please, because those numbers are the meat of your dialogue, what you're speaking. For example, if you were to look at it on an analyzer, if you could actually see the audio, like my audio right now doesn't have a whole lot of lows, doesn't have a whole lot of highs, but the meat of it is in the range that Jason just expressed to you. So, matter of fact, I think he's putting something up on the screen right now, so you can see that down there in the lower register that there's a lot of information on my voice, and there's even more on Jason's voice. Jason, why don't you say something?
All right, Kevin. Yes, I'm hitting some buttons here, and this is a scope. It's a really cool program. So yeah, Kevin, tonight we're going to be kind of talking about, you know, the difference between a condenser microphone and a dynamic mic, and how would you explain the difference, or when would you want one and not the other?
Well, the condenser microphones are typically associated with being better, but the word condenser microphone actually comes from a very similar word called a capacitor. So the condenser microphone typically requires power. It requires phantom power or a battery that you install on the microphone. And what the battery's for is the battery's used there to run the little, charge the plate typically, and run the little impedance matching network inside there, and brings it out to the typically a 600 ohm load. Now, the reason the condenser microphone is set up that way is they're typically more sensitive. They have better high frequency response, better low frequency response, and you'll find that they're very, very, very good microphones. And nowadays they've making them so they're very, very cost effective. Now, that's not to say that there aren't some great dynamic microphones out there. So like I said before, no hate mail, please. There are very good dynamic microphones out there, but that's a real brief description of the condenser microphone. It has a little impedance matching device inside. It requires power to do that, and it typically has a better or wider frequency response and more sensitivity.
Excellent. And you know, kind of where we're going with this, as you know, a lot of your radios come with some kind of hand mic, and you know, we like to get a little creative and hook up a different microphone to a mixing board, whether it's on a boom mic or you can hold it in your hand. And the big picture is and I did a little research on this. This is nothing that I made up, and it can definitely vary. But the human ear can hear about 20 hertz to 20,000 hertz.
Sorry, what did you say?
20 hertz. 20 hertz
to 20,000 hertz.
To 20,000 hertz.
Oh, okay, thank you.
Okay. Yeah. Or 20 kilohertz. A lot of times you'll see that K, the lowercase k. And a lot of times in adults we top out at about 16,000 hertz. So 16K hertz of what we can hear. When things go higher than that, we just can't pick them up as adults. But there is a percentage that can hear that. I've definitely heard females can sometimes hear a higher frequency, as well as children, and of course dogs. We've always heard dogs able to hear that high. The dogs can actually hear a range from 67 to 45,000 hertz. So again, we're down from 20 to 20,000. Dogs are 67 to 45,000. So pretty neat stuff. And then the next step is kind of getting into where the radio comes in. Now, it gets a little complicated in explaining the type of bandwidth the radio can give you, because that doesn't necessarily represent how much audio the radio can pack in there, filter it, compress it. There's a lot of magic that's going on in the radio. But just for an example, when we turn on our FM radio in the car, or our FM radios that we like to use on VHF, UHF, you're around 15,000 hertz in bandwidth on how much information you can pack in there. And of course, when you go down on HF, you're anywhere from 2,000 to 3,000. 2,400 is a pretty sweet spot. A lot of people use that. They call that the ability to break the pile up. But we're going to get in a little bit more. We got a bunch of microphones on the table to be able to show you, and we're going to give you some really cool examples.
I wanted to go back a little bit, and when you asked me about the condenser microphone, oftentimes a condenser microphone requires a power source, and something as simple as one of these little mixers that has, the input for it, the gain, which is the sensitivity, a volume control, and then the output can go into your radio. So you can get these, condenser microphones to work on your ham radio, but you'll also require a connector. You'll need something like this to get your microphone into your radio, or your mixer into your radio. We'll talk more about that later. Anyways, what we want to do? Play with a couple microphones?
Yeah, let's do that. So, okay. What microphone should we? Well, I'm sitting right here, so I can do these two.
All right.
So right now I'm on this condenser microphone, which hopefully I'm not overdriving.
Yeah, condenser microphone number 1.
Yeah, and so I'll pull this down here, and I'll disappear. You can probably hear me over there. And now I'll bring this microphone up, this here dynamic microphone. I use a dynamic microphone inside my office at home, and I like to use that whether maybe a little online gaming, or if I need to do a voiceover for a video. And the idea is this a lot of times will cut some of the background noise, because as I pull away from here, it quickly disappears. A dynamic, you for the most part have to get right on top of it, and the comparison would be dropping that down and bringing up this condenser. So I'm on this condenser, and the range becomes a little bit greater as far as where it can capture me. It'll also pick up some background noise. So that's kind of how I use the condenser and dynamic microphones.
That's a good example. Another thing too, we get asked the same question over and over again. Man, I'm in a band, or I have some extra microphones left over, whatever. What microphone would you use? Well, here's just a sample of the microphones. The one that Jason was just demonstrating, that's a Shure SM58, which is a very, very common microphone. And for those of you out there that are familiar with the Shure microphone, this is a Shure Beta 58. So the Beta 58 has a little bit different contour to it. It's got higher gain before feedback, which doesn't really help us in the ham radio business, but it could help us on the stage. So why don't we set that microphone, number 4, and just actually do this. Plug it in, bring up mic level 4, and just say something to the microphone, Jason, and then just leave the volume control in the same spot and swap it. So number 4, ooh, that's a hot microphone.
Well, I got to give it a little extra to drive it here, but so now I'm on the Shure 58 Beta.
Beta 58.
Beta
That's the
58,
newer version.
and I believe the cost, and we're not going to really go over cost tonight, but
it's more money.
This is more money than the standard 58, which I think has been around for a lot of years. 300
years, yeah.
I wonder how many nails were pounded in with this.
A lot. Matter of fact, there's people that say have demonstrated pounding a nail in. And the Shure SM58 is a $99 microphone, by the way.
And that's what I just switched to now. So I'm on the 58.
And we didn't change any of the settings.
Yeah, no settings were changed. I apologize if it popped a little bit. Sometimes I try to bring down the slider.
We're not going to do that for these next 2 mics because we want the level to be the same on the mixer. So you can hear, hopefully, on your speaker, as long as you're using a 27-inch coaxial speaker. That's a really bad audio joke. Just a decent speaker, you should be able to hear the difference. So that's the Shure SM58. So just for the heck of it, here's a D5. This is a AKG dynamic microphone. That's just that's a D5.
All right, so we're going to pull out the Shure 58, and we're going to drop in this AKG. Now, I might have missed it. Did you say this is a condenser or a dynamic?
That is a dynamic. It's called a D5. It's a dynamic.
Right. Let's pull it out.
The reason these are all dynamic microphones. All of these will work with your basic microphone adapter from hamradiotvshop.com, and other places have them too. But this microphone will plug right into here, and this will plug into your radio, and these dynamic microphones will work without any extra modification.
All right, so I'm plugged into this. Not sure. I haven't really been looking at the audio to be able to tell the difference, but you just kind of let a cat out of the bag there. We haven't told anyone yet, but that's okay.
Well, wait. It's going to be on HRTVshop.com.
That's right.
You know what? I'm no hate mail. It's going to happen.
Well, I will tell people we got a lot of things in motion here at Ham Radio TV, and most recently I've got some pretty cool decals, stickers that I want to get out to people. And yes, we are building a website. It's under construction still, and it is HRTVshop.com. That's what it's going to be called, and we're going to have a lot of this audio gear there, as well as some custom cables to be able to plug in microphones to the mixers or microphones straight to the radio. This guy here, of course, would be for the Yaesu FT991A.
That's right.
All right, so you want me to swap the next microphone?
Sure. This happens to be an Audio Technica microphone. This is the ATM27, and I just randomly grabbed these microphones from the pile of microphones. And the reason I did that, all of these microphones, except for the Beta 58, except for the Shure Beta 58, are all in the $99 range. So you could hear there's a little bit different timbre to each one of them. So try that Audio Technica microphone, Jason.
All right, so now I'm on this here microphone. Looks like maybe the levels are a little lower. I can't really tell.
Seems to be a little bit different. Yeah.
And is there a discipline when speaking on dynamic versus condenser as far as how close do you want to be? Do you want to get right into the mesh?
The proximity effect on those microphones, the dynamics you're using are far greater than these are. The Beta 58 was set up where you need to be pretty much on axis and speaking directly into it, because this was designed to give you a higher gain before feedback on the live performance stage. So if you're in your ham shack and you're just speaking on a microphone, it's always good to get, for example, if I speak off to the side, it's going to be quite a bit different in what we're into the dynamic over here, which is not plugged in.
Oh yeah.
So
I wanted to also so I'm going to drop my test mic, and I'm bringing up my condenser mic. So now I'm on this here black mic. Let me just see what you're seeing here. I am screen handicapped tonight. I normally have 4. Tonight I have 1, but that's okay. So I looked up the frequency bandwidth on this here AKG P120, and it said it was 20 to 20,000. In other words, this can replicate the human voice. It can capture the lows to the highs. And it had a sensitivity. Now, I don't really know what this means, but I wanted to capture this number. A sensitivity of 24 millivolt per PA.
Don't ask me to explain that. It means it's that means it's pretty sensitive. The higher the number, the more sensitive it is. And the SM58, go ahead.
And so the direct comparison on the SM58, which is this guy, a dynamic mic, that audio frequency bandwidth is 50 to 15,000. So 20 to 20,000, 50 to 15,000. And remember, as adults, we can't really hear that much once we go 15, 16. But there is obviously a difference. And not to mention the sensitivity is a lower number, a 1.85 bananas. Compared to a 24 bananas. You know, not getting into what that unit is, but they do have a unit of sensitivity for the extreme audiophiles.
And something, too, that I wanted to bring to your attention to, we're doing this on the YouTube channel so that your audio bandwidth is actually pretty darn good. And with that said, hopefully you'll be able to hear the subtle differences, and hopefully here in a minute, a stark difference between microphones. And I wanted to just take, Jason, can I take a moment and talk a little bit about the radio's response?
Yes, absolutely.
So the transmitter response on the radios vary from radio to radio. So if you happen to be an HF person, you'll look on your radio. You might have a Yaesu 991. You might have an ICOM 7300. You might have a ICOM 7610. And the list goes on and on and on. But the typical bandwidth of the average single sideband transmitter is approximately 2400 hertz or 2.4K. And then if the radio has a wide mode, it could be up to 2.8. And in many instances, it'll go up to 3000. So what that really means is you've only got 3000 hertz of bandwidth. So to have a microphone that responds to 20,000, well, the radio, for all practical purposes, started rolling that off at somewhere between 2,800 and 3,000 till it was non-existent. And someday in the near future, we will do a demonstration and show you what that looks like on an actual radio. Now, what's kind of interesting to me is the sideband radios, the low frequency response is pretty darn good, because a lot of those radios, the transmit filters get down very, very low in the order of 50 to 60 hertz pretty easily. And some of the stock filters, you'll look at it, they'll say they're 100 hertz to something like 2.8. Like my Kenwood TS940, it's rated at 2.8 is the bandwidth. And when you put it on a scope, it does start sharply falling after 2.8. By the time it gets to 3K, there's almost nothing there. But on some of the other radios that are available to you these days, some of the software-defined radios and other models that I did not talk about, the transmit bandwidth in some cases is continuously variable. You could take it all the way up to 4, 5, even 6 kilohertz, which is pretty dang wide. So you have to ask yourself a question. If I've got a radio that is transmitting, has a bandwidth of, 5 kilohertz on single sideband, that would mean that my person or friend I'm talking to would have to have a receiver that would do that. And it just so happens that we looked up two really popular receivers, and one of them is the Yaesu 991. And the Yaesu 991, I'm looking over here, it tops out received in the neighborhood of 3 kilohertz. And this ICOM 7300 tops out in the neighborhood of 2.9.
And that's the transmit.
And that's a transmit.
That's the transmit.
Now the receive on these radios, the receive on the 991, I believe tops out at 4,000.
Yeah, it goes higher.
It goes higher. It goes 4,000. And according to the specs, anyways, the 7300 is less. So what we're saying is, even though the microphones will go super high, that doesn't mean that your radio is responding to that. Just like these mixer boards, okay? There's a knob on here for, we'll call it the bass control, low, and it is functioning in the neighborhood of 80 hertz. So 80 hertz is going to get you something on your sideband. You're going to hear that. It'll make it muddier or less muddier. The next knob up here would be considered the treble control or a high frequency. This particular one is set at 12,000 hertz. You're not going to hear that on your sideband radio because it's way too high. Now, in contrast, real quickly on your UHF, VHF radios, like your, I don't know, just pick one. The frequency response is wider, but the low frequency response for PL use or the tone, there's a filter in there, because you'll find that most of your UHF, VHF radios, they tell you that their response is somewhere in the neighborhood of 300 to 3,000 or 300 to 4,000, something like that, for communications grade audio. Well, on the lower end of the spectrum, below 300 hertz, that's where your PL tones live, or your sub-audible tones live. And your sub-audible tones live somewhere, are generated somewhere between 67 and 300 hertz. They top out at 260 something. So if your radio passed that audio to the speaker and your repeater was putting out a 250 hertz or in that neighborhood PL tone, you would hear that tone on your speaker. So on your UHF, VHF ham radios, most of the time the filters are in there so that that tone is not audible through the speaker. There are times you'll hear somebody say, hey, I think I hear your PL tone, because maybe their PL tone on their transmitter is turned up a little bit too loud. It's deviating too much. And if that's the case, you might hear it leak through. But for the most part, we don't hear the PL tones because we don't want to hear them. And we get a little bit better high frequency response, a little bit more fidelity throughout the audio range because the FM transmitters are much, much wider in bandwidth. So what I was thinking about, why don't we do a real stark difference? Maybe we can let them listen to this other microphone, the communications microphone. And then, they have the little spectrum analyzer thing up on board? Okay.
Yeah, so you want to listen to this one?
Yeah, I want to hear the stark difference.
You want to do it here?
I'll do it.
Okay.
So I'm going to now turn off this microphone so it doesn't interfere. All right, so now I'm on this microphone here. So now if we put this, can we get the spectrum analyzer up on the screen? Because I want to do a little quick demonstration. Okay, so there's the analyzer, and I'll look at that and see what that audio looks like. Now I'm going to generate my own noise source, okay, some white noise. So I'm trying to, now my lower part of my register is there, you can see that. Now what I'm going to do is, now that you've heard this thing, now I'm going to switch over to the my condenser microphone. Now I'm back on my condenser microphone, and wow, look at the spectrum light up. Now I'm going to do my noise, my fake noise again. And notice that on that, it was a much wider spectrum, and it went much higher in frequency. And here on, hopefully in YouTube land, you could actually hear some of that. But on the ham radio, stuff up above 4 or 5 kilohertz, that's not going to help you. Now, there are those that will say that, hey, the better microphones with the better presence, and it's generating that. Yeah, the more information, the clearer it can be, and it's radio to radio how it's going to work. And you've probably, if you do this, Google extended single sideband. There's a group of guys out there that modify their radios. They do enhanced extended audio single sideband. It's really pretty cool, but the average radio won't do that. Those guys do a lot of work to make it work out. So that was a stark difference, I hope, in microphone audio.
Do you think we covered it all?
Yeah, there is one thing I wanted to show everybody.
One more thing, a lollipop.
Oh yeah, here's the cool for all you radio guys out here, here's the static D104 microphone, which is not hooked up to our audio system here in the studio lab, but I thought I'd show this guy here has a really good sound. It's got the mid-range or the mid-range frequency presence of this, but it's got more well-rounded audio than that communications mic. And depending on which one you get, mine does not have the audio preamp built into the bottom of it. And if it did, there'd be a little circuit board and there'd be a little screwdriver adjustment to adjust the audio. This is just a standard, a static D104. You grab it. And one of these days, I'm going to clean it up, and I'm going to put this puppy on the air because I think it's so cool.
Please subscribe if you're not already. This is part of a several video series that we've kind of started. You know, we have talked about microphone cables in a previous Wednesday show, and we did a little bit of a deep dive or a medium dive onto the microphones, and we're going to be talking about mixers here in a little bit, because the idea is we want the ability for people to understand enough to start putting together their own shack, you know, however they'd like to do it. You know, I mean, if you're happy with a hand mic, then no problem. But I think you start getting a microphone and a mixer in the shack, and it really becomes a lot of fun. So, Kevin, thanks for having me over here.
Well, thanks for coming over to the VLF Labs, where we just play with ham radio gear and try to share the ham radio love.
That's it. All right, guys, we'll catch you next week. Thank you.